Okay. Here's an update on the Multishot calibration instrument. Right now we're going to walk through the main components, and then we're going to run through a process manually to demonstrate how everything works. That's the HMI PLC. We'll turn that on. It's booting up. And it's going to start in what we call our sandbox mode. And we'll get more on that later on. Back here we have the signal conditioner for the linear encoder, the controller for the linear servo, and through this is the linear encoder. It's going to make the measurements. And here we have the compound probe. This probe will allow the measurement of the pusher in the beginning to the 0.210 distance distal of the cannula, and also it'll allow us to set the clip by referencing the rails and detecting when the clip is in the right position. Now it does this by changing its configuration. Let's see, where are we here? If you look at the tip right now, it's flat, and that's in the initial position where we would do the 210 measurement, and then in this mode the blade protrudes, and that blade would reference the tips of the rails, and then that will allow us to detect when the clip is in the right position. Okay, moving on, we have the trigger activator, simple pneumatic cylinder. We have the decoupler. This is something new we had to do from the original concept that we had, which was to use an electromagnet to simulate the coupling and decoupling here. So right now we will use the gripper to grab onto the coupler, and then we would decouple and couple like this. Okay. Then moving on here, we have the linear motor. This is from the original proof of concept, and that linear motor will allow us to control the activation of the button. Okay, the rest here is just what's needed to get things done at this point. We're activating everything manually to verify that everything works before tying it back to the PLC. The PLC, however, will run the first sequence, which is to set the pusher just proximal of the tip of the cannula. That's also something that was new from the original concept. So we tested the code required to get that done, and we're going to be demonstrating that in a minute. Okay, so I'm going to set this thing up to run, and then we'll get back to it. Alright, we're going to go through the first stage of the calibration process, which is to set up the pusher so that it is just proximal of the distal end of the cannula. Right now it is distal of the distal end. The system is in setup mode right now. The coupler has been coupled. The threader, so we'll couple it so it's in reverse mode, and we'll bring the probe in. The probe's in contact with the tip. So now we go over to the HMI, and we start the production process. Okay, you can see the increment of the pusher as it's moving on each stroke. We're moving slowly right now because we're in a test mode. This represents the difference between one stroke and the next. So we're monitoring this difference until it doesn't change anymore, at which point we know that the probe had stopped on the tip of the cannula while the pusher is continuing forward. So right now it stopped. It's going to continue for 5 cycles and then shut down. And at this point we're sure that the pusher is in the right position. And now